Hey guys, hello. Can you hear me all good? Turn that up a little bit. How's it going? Just let me know this is working alright now. Seems to be working okay. Double echo, okay. Oh yeah, I see I've got two input devices. So I'm not sure what mic this is that it's picking up. How does this one sound? So I've got this mic here, which is microphone number 1. That might be the same one. So this is mic number 1. Got mic number 2, or mic number 3. What one sounds best? 1, 2, or 3? This is number 3. This is mic number 2, and this is mic number 1. So no, 1, 2, or 3. Mic 1 is trash, okay. This is mic 3, so this is number 3. 1, 2, 1, 2, mic check. And this is number 2, 1, 2, 1, 2, mic check. Most people are saying 2, I reckon. Yeah, I don't have my RTA mics hooked up because they're still disconnected from when I did my video in the lounge. And the last stream I did, I used my built-in mic on my Logitech StreamCam, which was very kindly donated to me on the stream from a kind viewer. But I can't seem to find the wire that plugs in to the PC for that, so that was why the stream was meant to start half an hour ago, but didn't, because I was trying to find the wire. Couldn't find it, then I had issues with OBS, so it didn't get started until just now. How's it going, man? 9:30 in Indiana. What's up, what's up, what's up? Cool, man. Glad to, hopefully some of you guys will stick around for a bit. I'm just going to kind of have a chilled stream today. I don't actually know if I'm going to fix anything today. Kind of caught up with the majority of stuff. I've got quite a few amps that are here that I either can't fix because parts don't exist for them, or that I can't fix because I can't fix them because I've given up for the time being. Got lots of amps up on my racks over here. Quite a few bits and pieces that have just taken too long and that aren't really worth the repair based on the time, so it's only really worth fixing them when I get some free time. Is there going to be more Class AB repairs on the channel? Probably not, and the reason for that is because Class AB amplifiers don't fail. Like, I don't get to choose what I repair on live. I just stream what comes in. So if Class AB amps don't come in, then you don't get to see them being repaired. And they don't tend to fail as often. Class D bass amps are much more prone to failure, so that's why you don't see as much Class AB stuff on here. Yeah, I wish I could use my headcam mic, but I have no idea what I've done with the USB-C to USB-A wire. So, can't use that just now. Mic 3 is loudest. I can actually probably artificially boost this one. Hang on a sec. Let's boost the one that I'm using just now. Gain. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Okay, so that should be louder now. Let me know if that clips. I don't want it to clip because it sounds disgusting. I've boosted it by about 7.5 dB. So basically, guys, yeah, stream today. it's just going to be some Q&A. Just wanted to kind of hang out with you guys. Like I say, I've kind of caught up with a lot of work at the moment. Work isn't going great, to be honest, at the moment in the UK. I don't know about other places in the world. Partly due to the cost of components, like some of the MOSFET prices and chips and stuff like that have gone up by 5 times the price or 10 times the price. I actually looked up how much it would cost, right? So check this out. Maybe I can do this for you, right? So here we have a pretty popular amplifier in the UK at the moment, which is, if I just go to here, 30 people watching, that's fine. So in the UK, and you have these elsewhere in the world as well, just under different brand names. You have Vibe M21K. So this is a modern-ish full bridge amplifier from Zen Factory in Korea. I've done a video on these actually. They are basically the old Korean circuit using the same drive architecture and everything. They're essentially two half-bridge Koreans but on the same PCB and push-pull. Okay. So these amplifiers are this much brand new. That's the RRP. I doubt most people are paying that. But this is a 10,000 watt RMS amplifier, 10 kilowatt amplifier. That's not too bad of a price brand new. Okay. The thing is lots of people got these on like a discount or like on special price because really they didn't sell particularly well. The UK market is not really that great for these. So if we go ahead and have a look on eBay, let's see what these have sold for in the past. So we're going to Vibe M21K. Let's see if any on eBay have sold relatively recently. Scroll down to sold items. Let's have a look. I just want to kind of give you an idea as to what these are worth on the used market. Why does eBay user interface suck? I click sold items. Okay, so no listings. What we got here? Here we go. So this one here sold for £700. £700 again. I've also seen them on Facebook Marketplace. Someone says there's an echo on the mic. Oh yeah, that's my bad. That's because I had the JVC one enabled. Sorry, my bad for that. Echo should be gone now. So yeah, this is a amplifier which costs £1,300 brand new, but generally they sell for between £400 and £700 on the used market. So how much does it cost in parts to repair this? So bearing in mind, on the used market, this is the most it will generally see it sell for on the used market. I generally tend to see these go for between £400 and £600 on the used market. So let's go to Farnell and let's look at how much the parts cost to repair this amplifier. So we've got power supply MOSFETs. We have IRFP 7530 PBF. And there are going to be 2, 4, 6. I think there are. Let me just remind myself how many of these there are. Does this one show a guts pick? Nope, there is one on Google though. Someone at my door, one sec. Talking of parts, just got a delivery from RS Components. Cool. So, yeah, let's just remind myself what we have in this one. Because I added this up the other day and the parts cost is getting ridiculous. So you can work it out in US money. The exchange rate is all over the place. It used to be about 1.5 times. So £1,000 is used to be about $1,500. I think £1,000 now is probably more like $1,200, something like that. Okay, so in the power supply section we have 1, 2, 3, 1, 2, 3, 4, 5. I It's really hard to see this because it's so bright in here. 1, 2, 3, 4, 5, 6. Okay, so we've got 24 power supply FETs. So we need 24 of these. Okay, and then the output MOSFETs are IRFP 4868 PBF. And for this one we need, I think it's 12 of these. I think it uses 6 per side. Yep, so we need 12 of those. Then we need IRS21844S, 2 of these, because these often die. So these are not in stock at the moment, but if they were, we'd need a couple of those. See if I can just add them to my basket anyway to give you the thing. And then we're going to need some gate resistors and some drive transistors and stuff, but they're not going to be that much money. So generally, this is going to be how much it costs in parts to rebuild this amplifier. When these amplifiers fail, they do fail catastrophically, and they are generally a full rebuild with all the output MOSFETs and power supply FETs needing to be replaced. So to repair this amplifier in parts, we're at about 180 to 200 pounds once we paid for maybe some shipping or some extra sort of like drive transistors or whatever. So it's between 180 and 200 pounds to repair this amplifier. Okay, this amplifier in fully working condition sells on Facebook and eBay between 400 and 600 pounds. On eBay you're going to generally see a bit more because they take a fee, but these sell for between 400 and 600 pounds. So that's 200 pounds in parts. So if somebody wants to get this amplifier repaired, they're generally not going to want to pay similar to what it would be to buy a brand, a working one on the used market. So if I've got to pay 200 pounds in parts, this amplifier is going to take quite a while to repair because it's quite a lengthy repair process. There's quite a few MOSFETs to replace. These are all large package FETs, a lot of solder, a lot of time soldering, desoldering and whatnot. And also these amplifiers, they actually have, if I've got an example here, I can show you the heat sink pads look like this. Can I get the top down? Here, let me just unplug this and re-plug it back in so it's not green. So this is what the MOSFETs look like on these amplifiers. They're soldered to these sort of little thermal pads, which are electrically isolated but thermally coupled. So basically, if I want to replace all the MOSFETs, I either have to remove all of these from the original MOSFETs and then resolder them to the new MOSFETs, or I have to supply my own thermal pads, which is quicker. So I've got some thermal conductive tape here, which is quite expensive. So I either have to spend a bunch of time desoldering these and resoldering them to the new MOSFETs, which takes a long time and a lot of energy, a lot of heat energy, or I have to replace the thermal pad, which adds extra cost as well. So not only is it an expensive repair, but it is also time-consuming repair. So that's going to be about 180 to 200 pound in parts. So if I'm spending like a whole bunch of hours on this, I want to ideally try and make somewhere in the region of 150 pounds, in time on this. So if I'm paying 180 pounds in parts and 150 pounds of my time to go through, dismantle this whole amplifier from the case, remove every single MOSFET from this board, every single drive transistor, all the drive ICs, the gate resistors, replace 24 power supply MOSFETs, replace 24 gate resistors, replace, I think it's like 12 drive transistors, 12 output MOSFETs, 2 drive ICs, do new thermal pads or resolder the old thermal pads, new thermal paste, reassemble, endurance test. For me, that might get me, I don't know, about 150 pounds, which is about 170 bucks. That's going to cost the customer about 330 pounds with me making 150 on it, which is not that far off what the cost of a working one would be. So the issue with repairing amplifiers at the moment, for me anyway, is that firstly, parts are really expensive. Secondly, amplifier brand new prices and used market prices are coming down, and so people are just generally getting a different amplifier rather than having the amplifier repaired. And there's just less stuff coming in. People don't have so much money to go about repairing the amplifiers at the moment because of all the cost of living crisis and stuff. So people are saying that my labor is too cheap. The problem is, if I charged any more than that, then like you've seen, lots of these repairs would just be non-viable, and I wouldn't have any work, because I'd give a quote for the repair and people would say, oh, well, I might as well just buy a new amplifier then. So this is one example with this Vibe M21K. The same goes for the Brazilians. Like if I get like Tower Amps or Stetsum or Power Sound Digital, something like that in, the cost of these amplifiers is so cheap. So the time it takes me to repair and the cost of these parts just makes it not viable for the customer to actually have these things repaired. So it is difficult at the moment. So yeah, not really got a lot of work in. And so I've been trying to rack my brain a little bit and come up with ideas of what else I could do, because I like making YouTube stuff. And I've had this idea in the back of my mind now to make a new sort of series on YouTube, and it would be like the repair videos and live streams I make are just very kind of low effort. I just whack on a camera and start streaming whatever I'm doing. But I've had an idea in my mind now to do a YouTube series that would be very professionally edited and produced, nice lighting, really, really good shots. It would take a while for me to produce each episode, but I think the effort would pay off. So I want to talk to you about that, and you guys might be able to help me set up for that, because there are some aspects of this idea that I've had that I don't know a lot about, mostly 3D printing. So this is going to be audio related. This is going to be very, very audio related, and I think it will be a really popular series. So just to kind of give you guys an idea as to what it might end up looking like, if you don't already, I highly recommend checking out, because my series will be based on this. There's a guy on YouTube who is called Major Hardware. Really, really nice guy, really, really fantastic guy, and he has a series called the Fan Showdown, which for some reason the algorithm has decided not to show me in the last few months, so I've got a bunch to catch up on. And what he does on the Fan Showdown is he takes a Noctua fan shroud, like fan motor hub and case, and he 3D prints user submitted fan style designs. So basically people send in, email him designs, like new fan blade designs, and he 3D prints them and puts them all head to head. And it's a really well produced series, and it's really fascinating because these kind of thermodynamics of airflow and fans is quite well understood at a really expert level, but there's still a lot of like real world stuff that goes on that doesn't necessarily work on paper, or stuff that works on paper that doesn't necessarily work in the real world, similar to acoustics. Like that, you can do a lot of modeling, a lot of thermodynamic modeling and computer simulation and stuff of the airflow, but sometimes it breaks down in real world, sometimes it doesn't, sometimes it works exactly as intended. But it's a really cool series, showcasing designs that people think would work really well that just fall flat on their face, and other designs that look like they won't work but actually work really well. So my idea for the longest time has been to take inspiration from that series and do the same, but with a speaker enclosure. So what my idea is to start a series where I have a 3D printer, I have a standardized setup, I have a standardized driver and a testing environment with RTA microphones and SPL Lab pressure sensor, all sorts of things like that. And I give the community, you guys, dimensions, specifications of driver, maximum enclosure size, and you jump onto 3D modeling software and design what you think will be the best performing enclosure for this driver given the circumstances which I provide, similar to in the Fan Showdown. Then I choose 3 designs that I like the look of, 3D print them, and put them head to head in this controlled environment and see what kind of changes to the internal structure of the enclosure, see what kind of different port areas or T-line kind of designs or horn designs or all sorts of random crazy ideas that I know lots of you will have had in your back of your mind for years. You're like, oh, I wonder what that would do. I wonder what would happen if you put the driver box like this, or what happens if you made this weird shape or this port, or if you ported it again or had 2 different ports. I'm sure lots of you have had all sorts of ideas like that. and it's difficult to sometimes make those things and prototype those things with wood, especially if they're very complex, because you need to be very skilled in woodwork to make that happen. You need to have the free time and the resources and the skills and the tools available to do that, whereas with 3D printing, that allows you to basically create whatever you want with no skill. However, the only downside is that this will be on a reduced scale. Now, obviously, 3D printers can't make full-size speaker boxes. Well, I'm sure they probably can on an industrial level, but on a home enthusiast level, you're limited to a certain print size. So my idea was to do a kind of miniature version of this. So the driver would be like a little 2-inch or 3-inch Tang band or Dayton subwoofer driver with an FS in the region of 50, 70 hertz, maybe up to sort of 150 hertz. And I would build out of wood a sort of test cabin, if you like a scaled down vehicle cabin that's the right kind of shape, like a average vehicle cabin shape. We test the resonant frequency of the scaled down cabin, say it's around about 150 hertz of or 200 hertz of cabin resonance, and then we would fine tune the driver that I choose to be a scaled down version of like a 12-inch sub that you might use in a car that would be scaled up. So we're going to do this on a scaled down size thing. And I think that if like the kind of results that we end up seeing in these tests and from these experiments, I believe would be able to be scaled up and would have the same results scaled up on a lower frequency in a real cabin. So I think it would be really fun and useful data, useful information. I think it would make a really, really cool YouTube series. I can see it probably getting lots of views, and I can probably see it end up getting sponsored. I've never done sponsorships on my channel. The channel's not really big enough. I have my channel monetized, so you probably get adverts, but I recommend using an ad blocker. Like, I don't really get much money from YouTube at all, but I can see this series maybe being really popular, and with the effort that I put into it, I would quite like to get sponsorships from it. Most YouTube series that have a lot of effort and money poured into them generally are sponsored, because that's how it makes it worthwhile for the content creator to actually do that. So I think that the information, the entertainment value that you'd get from it would counteract the 10 seconds of sponsorship you have to skip through. So I'd love to hear your guys' thoughts on it, and I can talk about some of the testing methodology that I've had in mind for it, so we can go a little bit back and forth. But also, I don't know absolutely anything about 3D printing. I've done a little bit of research on what kind of materials would be good for making a 3D printed speaker enclosure of that size. Obviously, with it being very small, that's beneficial for the kind of 3D printed material. It's not very strong, but with it being small, it should be rigid enough that it wouldn't have any impact on the performance of this small enclosure. If we're going to be tuning it to sort of like 150 hertz or something like that, it should be absolutely fine. But I'd love to get some of your guys' suggestions about 3D printers as well, and what kind of ones I should really be looking into for this. So let's have a look at some of your guys' thoughts on this. Good morning from Tampa, Florida. How's it going? How's it going? Catch the stream later. No worries, man. Thank you very much for jumping on. Yeah, it's a really, really interesting series. Yeah, for some reason the algorithms decided to stop showing me the videos, so I need to go and catch up on a whole bunch of them now. Kind of like the aerodynamics of road cycling bike. Lots of opinion between what is on paper and what you see in real world. It's the same as acoustics. Lots of opinions about what types of enclosure are the best, what kind of shapes and stuff make a difference in real life. There's lots of documented stuff and lots of opinions, and not a huge amount of actual like back-to-back testing between all these different ideas. Yeah, I've seen Hexybase, I think, whatever his name is. I've seen his 3D printed enclosure stuff that he's done in the past as well, which is really cool. But I don't know if he's done much scientific kind of back-to-back testing, or like community kind of done community stuff where people have sent him in designs and he's printed them and kind of looked at them back-to-back. I know, obviously these enclosure type things are going to be pretty long prints and probably pretty costly in material, but I think it could be interesting. So maybe I should get in touch with Hexibase and just see if he's got any suggestions then. Yeah, I'd forgotten actually that he has done a lot of this, so maybe I'll get in touch with him. How's it going? How's it going? So basically, in terms of a 3D printer, I have come across one of these, which is just around the corner from where I live, which is really, really, really handy. So there's an Ender 5 Plus, which has a decent enough print bed size, maximum print size, of 350 by 350 by 400. So if we throw that into Basebox Pro, oh man, why is Windows Search so fucking shit? So with this 3D printer that's just around the corner for me that I can go pick up, we can have a look at what the maximum size box that we could print out with this would be. So we're going to go for external dimensions, millimeters, change this to mil, 350 by 350 by 400. I don't quite know what the wall thickness will be yet because I haven't done any tests on it, but let's assume, I don't know, 5 mil? 5 mil walls would be enough. So we've got a box volume that's actually bigger than I thought. 1.5 cubic foot? That can't be right. I'm sure it was less than that when I did it the other day. And if we did a vented box and we went to vents, we went for a rectangle port, I don't know, let's say 340 by 2 centimeters. Let's go 340 millimeters, not inches, by, I don't know, 12 mil, 100 mil long. And then the size of the port wall would be, because we're going to be doing 3 common walls, so it would be like probably 1.5. Oh man, why won't it let me change it? Hello? Why will you not let me change? So we end up with no damping. Is it going to give me a frequency yet? No. Why are we not giving me a frequency? Come on, give me a tuning frequency. Give me a tuning frequency. Move from database. Tang band, let's go. Let's just throw in a random Tang band 2-inch driver for now. No idea what this is, but that's fine. FS 155. Let's just load that in for now. Why is it still not giving me a tuning frequency for this? There we go. 43 hertz, 47 hertz. That is too low. But this is quite a big box, so we can tune to sort of 40 hertz with this. But generally, we're going to want the cabin resonance frequency of this small thing that we're going to build is probably going to be up in the 150 hertz range. So we can go down on the box size. Obviously, we don't have to use the full print size that this printer has. That would be great if we didn't, but it allows people to design 6th orders or T-lines or whatever for this size driver without being too limited on space. So the maximum space that we've got, yeah, is about it's about 1.5 cubic foot, which is way too big for the small kind of drivers that I was looking at. The drivers I was looking at for this series was going to be like a 2 or 3 inch tang band. If I go for the Ender 5 Plus, I could probably go for the 3 inch one. So if we go for audio components and we look at subwoofers, and we go for like 2 inches and 3 inches. These are some really cool little drivers. I have a bit of a thing for small drivers. They're really, really cool. This little guy, really, really cool, cute driver. This has an FS of 55 Hertz, which is ridiculously low for a 3 inch driver. So I was thinking of using something like this for our experiments, which could be really cool. It's a little neodymium subwoofer driver. You can see this guy's holding it. It looks really, really cool. So the recommended enclosure volume for this bad boy invented is 0.03 cubic foot. So yeah, we've got plenty of room to play with the Ender 5 Plus if we decide to go for that. So what do you guys think so far? Any thoughts or suggestions regarding 3D printing, or suggestions regarding this idea that I've had? For 3D printers, I have a Ender 5 Plus. Works really well for me. Paid about $500 for it a few years ago. So the one that's local to me is up at £350, which is about $380, I think. PLA will be fine. I was looking at some more premium filaments that would be really, really rigid, really stiff to prevent box flex, but on this scale, I don't know if that will matter, like you say. That's over a cubic foot, enough for a 12-inch JBL. Yeah, that's actually confusing. Is this printer bigger than I think? 300 by 300 by 4. I'm sure when I was looking at this yesterday, it wasn't coming out that big. 350 by 350 by 400 mils. What's that in inches? I suck at millimeters. 350 millimeters in inches. Let's throw it into Torres. Let's see what Torres gives us for an L-ported box. Oh damn, it's like 13 inches. That's massive. Wow, I had completely underestimated the size that this thing could print. 13.7 inches by 13.7 inches by 400. Damn, this is huge. That's 15 inches. That's absolutely massive. You can see how disconnected I am from millimeters here. I was thinking 300 mils is pretty small because millimeters is pretty small, but no, that's actually massive. Wow, okay, that would be sick. Maybe we could go up to a 4-inch driver then. Let's have a look at some 4-inch subs instead, and we can make the test bed a bit bigger. Right, let's get rid of 2 and 3. Oh no. Let's have a look, because I'm sure we can get some cooler looking subs that are in 4-inch, but I don't want to go so big that we end up putting stress on the enclosure. These are classed as mid-woofers. Now there's definitely some actual subs in this size. I've seen 4-inch subs before. Actually, the Dayton 4-inch drivers that I've got, that I did the video of years ago, would actually be perfect for this. Maybe I can even do it with a pair. Let's see what we've got in 5-inch. Nah, that's not really subwoofery enough. I want it to look cool as well. Part of the appeal of this series will be how the whole thing looks and how the driver looks, and how photogenic it is. So it needs to look cool. Something like, here we go, something like these. Something like this. I think that's a 5 1/4. Yeah, a little 5 1/4. That would be pretty awesome. These have really, really great mechanical excursion. There's the ferrite version and the neo version. What are the differences between the ferrite and the neo version? I suspect the ferrite version might actually be better. So same power handling, 1.2, the voice coil is the same, resonant frequency 45 Hertz is the same, so it's literally just the motor that's different. I suspect they've probably calibrated the motor to be similar. Let's have a look at the BL product. Do they have the BL listed here? 3, blah blah blah, VASP. Here we go. BL product 6.5 on the Neo, and so it's actually slightly higher BL product on the ferrite version. So I'll probably get the ferrite version. It's cheaper as well. But yeah, that's pretty cool. I don't think I'd want to make prints that big on the regular because they would take so long anyway. So maybe we should try and stick to it being small to start with. Start small, maybe start with the 3-inch or the 2-inch sub, and see how the series goes, and then maybe do bigger ones in the future for series 2 or something like that. People could also design for more dB versus more audio quality. That's exactly the thing. So I would let people design for whatever they like, I guess, or I could do different series. Like one series could be like just burp box, like what's the loudest like dBs you can get out of this thing. But there could be another series where we go for bandwidth, where we take an average of the dB scores across a range of frequencies, and whoever has the most bandwidth then ends up winning, something like that. Or I could just do kind of a general series where we are, people submit with their design, whether this is designed for just burp single tone output or whether this is designed for bandwidth, and we look at, we do tests for both to see what the bandwidth and stuff is like. I'd also throw the enclosure with the speaker in it on the DATS V2 to get impedance sweep curves, graphs and stuff like that to show where the woofer is being held still, what the impedance rise is like in the different enclosures. Also with the amplifier that I've got, whatever amplifier I decide to use for this experiment, obviously different enclosure types will allow you to throw more or less power at the driver before it reaches its mechanical limit. So different enclosure designs will have different efficiencies. So one enclosure design that someone sends in might be quite loud, but it might not actually take a lot of power. The driver might reach its mechanical limit too soon, whereas another design that gets submitted might be less efficient, might not be as loud at the same power level, but we can crank the power up and get louder than the other efficient box because we can throw more power at it. So we can really kind of fine tune these things, and I think it would be really, really interesting. Technically, with a 3D printer, you can build as large as you want. You can just print in multiple sections. That was also another idea that I had. Obviously, print it in different sections, have it interlock, and then glue it or screw it together, whatever you like. But I don't think I could go too big because then you start ending up getting into issues with the panel flex, because I don't know what the stiffness of the print materials are going to be like. Heck, mad expensive. Is that a filament type? I was just trying out resin printing as well. See, I did consider resin printing because in my mind I was thinking resin is weaker, but it's stiffer. Like I don't know really, because I haven't handled many 3D printed plastics or materials, but I was imagining that resin would have a higher stiffness before it shatters than a 3D printed plastic would do. So I was thinking, should I go for a resin printer? Would that be better for a speaker enclosure where it doesn't need to have huge strength, but it needs to have high stiffness? It needs to be resistant to baffle flex. But I did watch a YouTube video where a guy bends a bunch of different printing materials, and resin wasn't actually that stiff compared to some of the filaments. So. But yeah, maybe I could look into it. Maybe I could get a few samples made. Maybe I could like speak to somebody who has 3D printing printers, like resin ones and regular 3D printers, and get him to print the same enclosure a bunch of times and see which material works best for a speaker enclosure before I then decide on buying one myself. That could be something that we do. 3-inch does mean for madder designs, exactly. So if I go too big on the driver, then it limits what people can do in terms of crazy box designs, because it might not fit into the space or the print space that we have. Whereas if there's lots of headroom on the enclosure size, and people can like make some really wacky enclosure designs with like a dual kind of T-line that uses both the front and rear wave, or massive 6 orders or 8th orders, or really weird stuff that has a bunch of chambers to try and maximize the output. So I think probably sticking small, at least to start with, would be the way to go, either with a 3-inch or a 4-inch driver. You can design the internals of the enclosure. Yeah, absolutely. So that will be down to the community. That will be down to each user to design the walls of the enclosure in a way that adds stiffness or adds strength, bracing, a pattern to the inside of the enclosure for dispersion, if you like, something along those lines. So yeah. Only does it take a long time, but a lot of PLA. That's another thing. I've no idea how much each of these 3D printed enclosures is going to cost in materials. You could add internal camera and light mounts inside the box, and you could add smoke for visuals. That's not a bad idea. Yeah, I guess the smoke particles would accumulate in pressure peaks. So that might be really, really cool to see actually how people's designs are going. Can you print in translucent or see-through material? Because that would be cool, wouldn't it? Would be to print the enclosures either completely out of transparent material or at least like the top piece, so that you could fill it with smoke and then have a look inside and see where the pressure peaks are, see where the air is mostly pressurizing inside the box to help people with their designs. PLA prints fast too if you're not wanting glass smooth finish. I don't think it wouldn't need to be like the most amazing quality finish, because the audio waves are so long that they will ignore any tiny sort of surface bumps. When we're testing at these lower frequencies, we're probably going to be testing between 80 and 200 hertz. So any roughness to the surface is going to be negated by the audio frequencies. They're just too long to care about that. So I don't need super, super high print quality. It just needs to be strong and needs to be a decent size. That's another good idea. Yeah, I could have a benchmark enclosure and test differences between drivers. That would also be really cool. Peak filament can be 330 per reel. Is that like a special hard, strong type of filament? I guess I wouldn't need the most crazy stuff. It's slightly opaque. Okay. I don't know if translucent would work. I think it would have to be like fully see-through to see the to actually see like where the smoke accumulates. Or perhaps we just don't 3D print the top. Perhaps I use some plexiglass. Perhaps like we 3D print the enclosure, the main enclosure, but then the top is just like plexiglass or you know, whatever the hell else it's called. I'll just cut a piece of plexi to fit on the top so that we can see inside of it. That might be a good thing to go. So yeah, maybe then I should go and grab this Ender 5 Plus. Because literally, or I don't know anything about 3D printers or 3D printing. I just went on Facebook Marketplace and I just typed in 3D printer and hit like a 15-mile radius or something, and there was an Ender 5 Plus. So I don't know if that's a good one or not, but if you guys are saying that that printer would do me well and would be great for this kind of endeavor, then maybe I'll go grab it today. Maybe I'll start preparations for this today. What kind of print material would you guys suggest? If any of you guys know about 3D printing. So naturally, it needs to be somewhat rigid. Doesn't need to be strong. Like, it doesn't need to be able to be dropped and survive. It can be brittle, but it needs to have high rigidity. And it also needs to not be really expensive, because if I'm going to be printing quite large kind of speaker enclosures with this, and if I'm going to be printing 3 at a time for every episode, then it needs to not cost absolute fortune. I've had an Ender 3 Pro and had great luck with it. Nice. You can get wood filament. What is PLA mixed with wood fibers? Really? Would that be good for rigidity? You can get creative with 3D printing. 3D print my parts, put them in plaster, melt the 3D print part out. I'm left with a mold for my metal casting. Clever! I know nothing about metal casting. ABS needs enclosure. Go with PLA. What does it mean? What does it mean by enclosure? Does that mean that the whole 3D printer needs to be enclosed and kept warm? Cool. Most of you guys are saying these are good devices. PLA is fine. ABS can be a pain with warping. Start with cheap PLA so you can practice and get familiar with the machine first. That's a good shout. Would PLA with internal bracing be enough for a 2 or 3 inch speaker driver, do you think? PLA is soft and not heat resistant. PLA is good for prototyping. So soft is not good for negating panel flex. And ABS needs to be kept warm. Okay. Because yeah, the Ender 5 Plus is just an open thing, isn't it? What about your tutorial course for Amplifier? It's not really worth my time dedicating, like, doing a full Amplifier course tutorial thing on YouTube. YouTube won't reimburse me enough for it, just based on, you know, video views and ad revenue and stuff like that. You've already got Perry's guide on the internet, which you can pay, which is $40 for basically the whole amplifier repair guide. It's really good, and for anything more up to date, you can just watch some of my live streams and videos and you can pick up the rest of the information. If I was going to do a amplifier repair guide, or like, you know, whole kind of series, if I was going to do like a really in-depth like tutorial of how to repair amplifiers, I'd probably have to make it be a Patreon or something like that, where you can subscribe to the Patreon, and then there'll be like videos that go up that are specifically tutorials on specific areas of amplifiers or specific generic circuits and stuff like that, that would be really tutorial. There wouldn't be like a live stream like I do where I'm repairing something, I'm kind of telling you how to do it as I do it. I'd literally be actually tutoring you in a way that you could then do it yourself, that would be really easy to follow, and everything would be structured and stuff like that. But for it to be worth me doing that, it would have to be like a Patreon or something. There'd have to be some cost to it for it to be worth it. PLA just prints as long as you have a clean bed. That's what I like to hear. PLA 2 years ago was £20 1 kilogram. How much is it now, Cirrus? Is it really expensive? Has everything gone up? Has the machine you're after got a heated bed? I think so. Yeah, it does, yeah. So if you're a bit late to the stream and you've only just joined, I recommend just skipping back and watching through what I explained, because I can't be asked to explain it again. What I'll probably do is I'll probably cut that bit of the live stream and I'll just upload it as a separate video. So if you don't want to go back and watch it now, just I'll release it as like a little clip from this live stream, so we can continue chatting about it in the comments if you like. That's very kind of you, Cirrus. Thanks for the offer there. Okay, so based on what I have seen, I think that I should go and pick up this Ender 5 Plus from Facebook Marketplace, because it's just down the road. So I might go and nab that today, and then we can get started on this new endeavour. I think it'll be really cool. Hopefully it'll get lots of views, hopefully it'll get sponsored, and hopefully it will make me some decent living wage because I'm not able to support myself at the moment on the Amplifier business. It's not good. If there's enough interest in a Patreon or something similar to that, maybe not a Patreon, maybe a YouTube, what do you call it? YouTube community? No, what's that thing called? Where you pay money and get videos on YouTube? Something like that. If there's enough interest in like structured tutorial videos from myself on specific circuit areas, generic circuit types, really walking you through the repair process of power supply sections, how protection circuits work, how the output section works, what things to look out for. If you've got this issue, then do this. If you've got this issue, then do this. Like really well structured, well produced amplifier repair tutorials. If there's enough demand for that, then maybe I'll consider making it. But there needs to be enough demand for it to be worth me doing, because it will be very time consuming. So it needs to kind of match or exceed what I would otherwise be able to be making in amp repair. Although at the moment, that's not much. So it wouldn't need to. Members, yes, channel members. So it'd either be a Patreon or channel members. What do you guys reckon would be better, Patreon or channel members? I feel like YouTube is more accessible. I feel like Patreon's a bit, people don't have Patreon or go on Patreon that much, but YouTube is very accessible. So maybe YouTube channel members is the way to do it. If you want 90% efficiency on 2 ohm load, you probably want to get, for 1000 watts, you probably want to get like a 3000 watt RMS Brazilian amplifier, like a Powerus PW3500. Or a Taramps, the Smart 3, for example, would be very efficient at 2 ohms, as would the MD3000. And yeah, just run it at 2 ohms, which will give you about 1500 watts RMS, and just turn it down a bit to get you back down to your 1000 watts. The new modern full bridge amplifiers are incredibly efficient, especially when they're not driven to their limits. When you drive anything to its limits, the efficiency tanks, and that does occur with the newer Brazilian amps as well. But if you run them well within their limits, especially if you're wiring to 2 ohms on a 1 ohm amplifier, then yeah, the efficiency is going to be really high. You could do both. Yeah, I guess I could do both. If some people don't want to use Patreon or don't want to use YouTube members, then yeah, I could just upload them on both. That's, yeah, why not do both? It doesn't cost me anything extra to do both, does it? So might as well do that. You can slap a camera on the 3D printer and live stream that too while it prints. I don't know if there'd be much interest in that, but maybe there would. Okay, yeah, cool. Some food for thought then. So I might go and grab this printer. Let me just see, where is it? Here it is. So yeah, this is the one that I have seen that's local to me. Ender 5 Plus with 11 rolls of filament, multiple new nozzles, extra hot end, don't know what that is, and 2 extra glass beds. I would say that sounds like a pretty good price for all of that. These printers tend to go for similar to that amount of money on eBay anyway, just as they are, whereas this seems to have quite a lot of extra bits and pieces with it. So if you think that's a good deal, so this would be about, what's 350 in USD? With the current exchange rate, it's about 420. 420. So if you 3D printing guys think that seems like a fair deal, then maybe I'll go grab it. Maybe I'll go grab it today. Alright, you've convinced me. I think I'm going to go grab it. Great deal. Sweet. Sweet, let's message the guy and see if he's around. New toy day is always fun. Yeah, new toy day is always fun. This, I can't really afford to buy this right now, but like I can, but like I shouldn't. But if this is going to then lead to better YouTube revenue, new business venture, then I see it as an investment. Yeah, the Amplifier business is going really shit. I'm not making enough to live on because of parts cost, and there's less demand for repairs in the UK now, so I'm trying to find something else that I can do. I like making YouTube content. I feel like I can make this really good YouTube series work. What should be the rail voltages for a 1000 watt amp on 1 ohm and 2 ohm, sir? We can work it out if you like. If anyone wants to know how to work out what the rail voltages would be for a specific amplifier, we can find out. So firstly, what you want to do, you can do this all on a calculator, but we're going to use websites just because it's easier and more visual. So first of all, we're going to go to rapid tables. Okay, and this will tell us, so say you want 1000 watts RMS, okay, and you want it at 1 ohm. In order to do that, you're going to need a sine wave with a voltage of 31.6 volts. So that's what the voltage of the sine wave would be in order to produce 1000 watts into a 1 ohm load. So then we go to a different calculator. We look at RMS peak calc. I can't remember what the actual website's called. So look at this one. This is an RMS voltage calc. I need this one. Peak to peak voltage calculator. So this is the RMS voltage. Okay, so this is the RMS voltage of the sine wave to produce 1000 watts into 1 ohm. So in order to work out what the rail voltage would be, we go to RMS voltage as the input, which was 31.6, and the peak to peak voltage, which is here to here, is going to be 89.3. So that means that the rail voltage would need to be about 90 volts peak to peak, or plus minus 45 volts. So if it's a regular dual rail amplifier that has positive and negative rails, we need to have about 45 volts on each rail, at least. It'll actually be more than that, and I'll tell you why in a minute. But we need at least 45 volts on each rail. Or if it's like a Brazilian that uses a single rail and a floating midpoint for the ground of the speaker, then it would need to be a single rail of 90 volts. However, you will generally see the rail voltage be much higher because as you start drawing current from the amplifier, the rail voltage will sag down and it will actually reduce, just like voltage drop across your power wires or anything like that. So in order to actually have rail voltages of 90 volts peak to peak when it's drawing power, the idle rail voltages or the unloaded rail voltages will probably be somewhere up around the 115, 120 volt mark, something like that, in order to actually have a sine wave that can get to peak 90 volts before clip point. So in a 1000 watt 1 ohm amplifier, you're generally going to see peak to peak rails of about 110 to 120 volts. And then for a 2 ohm amplifier, you just do that again, but instead you do it with 2 ohms instead of 1 ohm. How close have you come to selling your DDZ4s? I definitely want to sell my DDZ4s. I don't want to keep them. The van will sell, the Z4s will sell. The Z4s were a bit of a stupid mistake, really. They're good subs, don't get me wrong. They're probably, like, in some aspects of performance, the best performing subs you can buy for money, but the performance of them isn't that much better than what you could get by spending a quarter of the amount of money. And also just so many issues with quality control with them. Had to send one of them back to the States already to have the spider redone and have it reconed, and now the other one is doing the same. So yeah, they're actually really shit. They're just so many mechanical problems with them. I don't even drive them that hard. Like, they should be able to take all this abuse, like, you know, just normal abuse that you would have running Z4s. I'm not even running them on as much power as some people do, and I barely ever use them. Like, I barely drive the van. I've done, like, in the last year, I've done one show and I did, like, some demos and stuff, and one started having issues. So the repair content won't stop, but I'm just not getting that many repairs in. So I have a quick question. Any idea what a PRV SQ3500X uses for the power supply MOSFETs? Not sure. Let's have a look at that, because I don't recognise that amplifier. Maybe it's one that we don't get over here in the UK. Let's see if I can have a look at the board pick. Images. Oh, this looks like a Brazilian copy. Okay, so it's going to use something like IRF. It's going to use 1404s or CSD and 18650s, I think they are, or 3077s. You can pretty much throw a whole plethora of high current, low RDS MOSFETs in there, from 35 to 80 volts drain source voltage. Anything above sort of 170, 190 amps continuous drain current, with a similar RDS to the 1404, 3077, should be fine. Indiegogo, people can donate one time or more. Have never heard of Indiegogo before, but I'll look into it. I want to choose a platform that is easily accessible and that lots of people know and use already. All right, let's see if this guy has replied with the 3D printer then. He said, yeah, he's in now if I want to collect. So maybe I'll jump off the stream and go and get this 3D printer and get playing around. If anyone wants to, basically what I'll do with this live stream, I will clip the section where I explain what the idea is, but I don't want. Do I want to do that? So I don't want someone to beat me to it, because lots of people will have 3D printers already, and I don't want someone to be like, "Oh, hey, that's a great idea. I already have a 3D printer and knowledge and experience. Let's do that and do it first." So I don't necessarily want to make it super public just yet, but I thought I'd jump on the stream because I know that you guys that watch the stream are genuine, nice guys. So I thought I'd stream it first and get your guys' opinions and ideas. So yeah, maybe I'll have a mess around with it for a bit, and then once I've decided I'm definitely doing it and got some experience with the printer, I'll clip this bit of the live stream, put it up on YouTube, and people can make suggestions on what kind of filament to use, what kind of things they'd like to see in the series, what kind of tests they'd like to see, how they'd like it structured, that kind of thing. That YouTube taking a large cut of the money. Talking of that, thank you very much, Scott. Man, $20, that's quite a lot of money. Happy New Year. Happy New Year to you too, Scott. YouTube takes, let's have a look into it. I know Super Chats, they take quite a lot of money. YouTube Super Chat cut. So YouTube takes, YouTube keeps 30%. So if someone sends me £100, I get 70. If someone sends me £20, I get $20. If someone sends me $20, then I get 14. So thank you very much for the super chat, Scott. I get $14 of that. I don't know what it is if for channel memberships. Let's have a look. We're doing YouTube channel memberships. YouTube cut. don't know what to search for. Well, membership's free to use, those cost you. YouTube will take a 30% share of your profits. Holy bananas. That's quite a lot, isn't it? Or is it? I know other platforms might take more. What do Patreon take? Patreon. What cut does Patreon take? For all pledges, $3 or less, 5% plus 10 cents. For all pledges up over, it's 2.9. So Patreon would earn me more money because it would be less of a cut, I guess. People already have 3D printed speaker enclosures, yeah, but they're not doing a series on it. I'm not talking about people taking the idea of 3D printing speaker boxes. I'm talking about people taking the idea of making a series of it and having community driven content based on that, because it would be quite easy to set up. But in terms of the amplifier repair tutorials, if I want to do that as well, then Patreon would definitely be, by the looks of it, the best way for me to go about doing it. But I know that YouTube members are more accessible. I might have to make the YouTube membership more expensive than the Patreon one because of the cut that they take. But yeah, guys, thank you very much for your insights on the stream. I'm happy to chill here and do some more Q&A with you guys. If anyone has any amplifier repair related questions they want to ask me that they're unsure about, maybe something they're working on, or maybe you're looking to buy something and you want some advice on what to go for, we can do a little bit of Q&A just now. Otherwise, I might jump in the Proton and go and grab myself a 3D printer. Because my guy said that he's available just now. James says, "Hi Sam, haven't had a chance to join one of your live streams in a while. Just wanted to say hi and hope all is well." Thanks very much, James. Appreciate you jumping on. It's good to see you here. I've also got on the bench, I've also got the audio pipe 3K mod. I was looking at this earlier today, see if I can make some more progress on it. The reason that it's taking so long is not because I'm actually doing much work on it, just because I kind of put it to the back burner for a while. And I got as far as pretty much sorting out all the main circuitry stuff, and I'm just winding the transformer. Like, I don't need to know how many turns to do, but I got a bit stuck with how thick I need to make the secondary, and no one could, like, I was sort of asked a few people, no one could really give me a definite kind of answer on that. Transformers are not really my strong point. I don't know a great deal about transformer design and stuff like that. So the thing that kind of got me stuck on the audio pipe and why it's just kind of been on the back shelf for so long is just because I wasn't really sure how thick to make the secondary. So the primary consists of a whole bunch of strands. It's really, really thick. It's, how many turns is it? It's 1, 2. So the primary is 2 turns each. And it's got like a whole bunch of strands. 1, 2, 3, 4. I can't count all these, but there's like a whole bunch of strands here with the primary. And the secondary doesn't need to be as thick, obviously, but I wasn't sure how thick to make it. I don't want to make it so thick that it's overkill. I don't want to make it too thin that it bottlenecks the transformer. I don't really know what would the output current be on the secondary. Off the top of my head, I'm not sure. This amplifier will have a rail voltage of about 190 volts DC. So my limit on this amplifier for rail voltage is actually the drivers. The voltage limit on the driver, the IRS 20957S, is 200 volts. So I don't want to sit right on this limit, but I want to get quite close to its limit so that we get some decent power out of this thing. So yeah, the rail voltage is going to be about 180. And that's going to be in push-pull, obviously, and there will be some rail sag under load. So I guess that this amplifier will probably try and make somewhere in the region of 8,000 watts RMS, something like that. So I could work out the current of the output transformer. This transformer came from a Band of Viking 7K. So I think they use the same transformer in the 8K as well. So yeah, this needs to be able to provide about 8,000 watts RMS to the amplifier stage. Please don't forget, at the end, you put a speaker on a plastic enclosure. Think about it. Not sure what you mean, buddy. Hey, that earthquake amp I was asking you about, when I put the 50 N20s in it, it jumped into protection. I couldn't find any faults, so I replaced them with 45 N20s and now it works. So yeah, those amps are very, very fussy with MOSFET type. So I thought that 50 N20s would be fine because they are very easy to drive and they're used in very similar circuits to this. But I haven't experimented with that exact circuit with different MOSFET types. So I assumed that the 50 N20s would work fine. Sadly, if they don't, that's a shame, but they're really useful FETs to have. They go in the JBL GTO 14001 and also the 7001 as well, and they're used in the B2MA 6000. Lots and lots of amplifiers use 50 N20s, so they're useful FETs to have around. So there's going to be some characteristic about the 45 N20 that is required for this circuit to oscillate. So if you've got a MK328, drop the 45 N20s in here. Have a look at the gate capacitance, the CG, and the VT of those original FETs and compare it to the 50 N20s. And if one of those values is wildly different, then that will be why it's going into protection. There are calculators. Okay, maybe I can look into that. Have you given up on your desire to design your own amplifier? Not really, but it would just be so time consuming. It would probably take me like 2 years, and I need something to make me money in those 2 years. So it's kind of like I can't devote my time to something like that without an income. Like if I had a 9-to-5 job and then I came home and I worked on my amplifier design in the evenings or something like that, yeah, fine. But that would pretty much use up all my time, and I spend a lot of time hanging out, socializing with my partner and stuff. We do a lot of stuff. So I don't think I can devote that much time to it. And also, I don't know if there's much of a market for it. I could design my own amplifier circuit and it could be great. And then I've got a great design. Then I'd have it prototyped, which would cost a lot of money. And the prototype works great. Then I need to sell it. So I either have it made in China or Korea or something like that, at which point it will be copied and sold for cheaper. So that won't really work. I could have it assembled here in the UK, but then the end cost to the customer would be so expensive. But also, even if I had it made in Korea or China or something like that, the end cost to the user would be still a lot of money because of the design process, that I'd have to try and recoup money from. That's why Rockwood Fosgate and JL Audio amplifiers are so expensive, because they are designed from the ground up. I don't think there's a huge market for a bespoke amplifier like that. People want the most power they can get for the least money. And when you've got now the Brazilian brands churning out 5K amplifiers for like $300, I can't really compete with that. Even if my circuit is like so much better, I can't, like my 5K amplifier would probably end up costing like over $1,000, and people aren't going to buy that because it's over $1,000 for the same amount of watts as the one from Brazil. So Okay, I'll give that a go. Thanks, Cirrus. I'll give that a go. Okay, guys, thanks for the stream. I'm going to jump off and go and grab this 3D printer. Wish me luck with it. You have to go into home audio. Yeah, that is true. Or pro audio or something like that. So I'm going to jump and go and get this 3D printer, and hopefully opens up a new chapter of the channel. Hopefully I can make this be really cool. So yeah, I'll catch you later, guys. If you've got any more comments or suggestions on this, or if you've got any questions in general, just message me on my BearVids Facebook page. I also have a Discord that I think the link for the Discord is in the description of one of my videos somewhere. The Discord is called Stanky Hot Fets and Stone Cold Sauvignon, which is a joke from Streamers a couple of years ago. Or just comment on this. I'll cut the part of this live stream out and probably upload it soon to get some more thoughts on the series. So yeah, nice one, guys. I'll catch you later. Take it easy. Have a good one.